Hello everyone, a very good morning to all. Dear authors and invited guests, welcome to the technical session 3A. My name is Anisha Mishra and I am the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2023 through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Bharat Singh Deora. Dr. Bharat Singh Deora has over 25 years of experience in the field of computer science as a faculty, researcher, software developer, and project guide. He is presently working as Senior Assistant Professor in Department of Computer Science and IIT of JRN Rajasthan Vidyapeeth University. Dr. Deora is also a member of various national and international bodies like CSI, Computer Society of India, ISTE, Indian Society of Technical Education, IEEE Institute of Electrical and Electronics Engineers, USA, ACM, Association of Computing Machinery, New York, USA, IEEE Cloud Computing Community, UACEE, Universal Association of Computer and Electronics Engineer, USA, IACSIT, International Association of Computer Science and Information Technology, Singapore, CDIWC, the Society of Digital Information and Wireless Communications, Internet Society, USA. Welcome to the session, sir.
Good morning, thank you. Hello.
Yes, sir.
I am audible?
Yes, sir, you are audible.
Yes. We start session or you?
Yes, sir, okay. Yeah, now we will start with the session. And
good morning, everyone. First of all, I am very thankful to Amit Joshi sir, who gives me the opportunity for chair this session, and congratulate all the entire team of the conference for the successfully organizing this event. And I wish all participants best of luck for their presentation. So we'll start without wasting time.
thank you so much, sir. And now we will further start with the papers. And I would like to invite our first presenter, Nayar, to present his paper on the title, A Discrete Firefly Algorithm Applied to Structural Bridge Truss Optimization. So, dear presenter, you may please start your presentation now.
Thank you all. Well, I am going to share my screen. Well, I am presenting from Mexico, so it's very late here at night. It is 10:30, so if I made some mistakes, it's because I am very tired right now. So please be aware of it, but I will do my best. I am going to present something that is related to structural optimization and the uses of evolutionary computation to optimization problems that deals with the topic of generating the best structure in an engineering, civil engineering context. In this case, this context has to deal with the problem of finding the best geometrical possibility in an environment that is defined geometrically. This environment also puts some restrictions about material possibilities and some other building possibilities that are the cross section. The schedule of this presentation is about how do we define structural optimization from an engineering point of view, and how is it related with the mathematical approach to the optimization problem, and how this approach has evolved over the time and over the few last decades, that has had a very, rapid evolution of the type of problem that we can solve. So in this regard, also we are dealing with the strategy of have to solve this problem of to solve this problem of structural optimization using these evolutionary algorithms, and how these algorithms have also evolved. And we are trying to also to how to say, to give the reasons why we are using the Firefly algorithm, that we managed to make it very efficient for this type of problems. So I'm going to start to present the problems. In the mathematical context of structure of optimization, we have some testing functions that in the sense of generating an optimization strategy, help to validate the use of a particular approach to optimization. But how these these functions look in reality? Some of them can look very simple, but most of them are very complex in the geometrical way of looking at it. Because if you want to solve an engineering problem, probably it's going to be more complex than the figures that we can see in here. And that is because in the reality, the engineering optimization problem, it is not a continuous problem that can be defined mathematically with just one function. This problem is defined in a context of a discrete space, and also with mixed variables, because some variables can be discrete and other continuous, like the geometry and the cross sections. That the cross section, for example, are the ones that are used for the members of a structure, no? That can vary in sizes or can vary in form. So the engineering problems are probably complexer than these problems that we can see in here in these images. But these problems look quite simple in the first hand, and we have mainly three types of problems. The first one that is defined in the left images of the screens are regarding the cross sections of a geometry of the bridge. For example, we can optimize bridges or houses or buildings and other type of structures. We can see here the profile of a bridge, and if you want to optimize this profile of the bridge, you can use different cross sections in the members of this bridge. But also you can well, you can modify the geometry of the bridge. You can move the arch that is below, and you are changing the position of this arch, and this position will vary the stresses in the arch and also the functionality of this same building or this kind of structure. But also you can change how these elements are connected or the position of these elements. And if you combine these three approaches to optimization from the structural point of view, you can generate almost an infinite number of solutions for this simple problem that could look very simple. And also, if you add the physical environment to it, it grows in complexity, because this kind of structure is going to deal with earthquakes, and it will depend on the context too, because if it is exposed to flooding or to hurricanes, it will add some more complex restrictions to the behavior of the performance of the bridge. And well, but from the engineering point of view, which are the problems that we are using to validate a methodology of optimization? Because a mathematical optimization strategy, it is not a guarantee it is not guaranteed to work in an engineering context. So it is not just valid that this strategy works in the mathematical context, because we have to test it in the engineering context. And this context is growing in complexity too, because from the first engineering validation problems, we have passed to a 10-bar problem to infinite bar problem solutions. So, and why is that? Because this type of problem with no restriction of the number of elements, it is closer, sorry, to the reality that we are dealing in some engineering problems. And also these problems deal with real physical demands or requirements. So how do we deal with the efficiency with the solutions? We are looking for lighter solutions, easier to build solutions, faster procedures to generate close to optimal solutions, precision in finding and near to optimal solutions. But there is, if you read this with this conscious to the engineering or the reality, you will find that this one in particular is very hard to approach, because we don't have a comparison or an optimal global solution to compare with. So it is very hard to find something like that. We can approach, but we just can say that we are near this solution. Yeah? That these points are talking about this. And well, and how do we do it? We have to deal with the exploration and exploitation capacity of the strategy we are using, and we have to deal with using minimum runs for these problems, because when they grow in complexity, they also grow in the computational cost of how to find these solutions. And also the market is demanding for novel solutions, because in the engineering perspective is not the only perspective to resolve the problem. We have to deal to political issues, to architectural demands, and also to user demands. So it is complexer than we have put it in here. But how are these strategies? how is the engineering and the mathematical experts dealing with this? They are proposing evolutionary algorithms since 1960s. The genetic algorithms started with Bremer, and were more put in the engineering context by Holland in the United States. But the popularity of these evolutionary algorithms is related with the facility to program this algorithm, because they don't deal with the mathematical formality of gradients or Lagrangians approaches that are limited sometimes to one variable or finding a local optimum. And we have a boom or an exploitation, well, how to call it, a good moment in these last 2 decades of emerging strategies that deal with the problem of evolutionary computation with a perspective of the swarm, for example. And where's the swarm? Swarm is in a approach that you work with several solutions at the same time, and these solutions explore a vast area of your sorry for my English, it's getting stuck, but you explore a vast area of your solution space. So, and this kind of approach is very effective, and it is a tendency to use it in a real timing context, as we can see in this machine. This machine is 3D printing a bridge that can also manage to optimize the form. At the same time, it is building the bridge, and it is taking information from the environment and put it in the geometry of the final form. So it is very interesting, the things that they are using with optimization too. So, and one of these algorithms is the Firefly algorithm that deals with the behavior of fireflies that moves according to the brightness of their light. And this light, it can be used to mate or can be used to eat. They attract other flies and they can eat it, or they can mate with them. And also, another important thing that is not very explored is the representation of the solution, because when we put the mathematical context strategy, the mathematical context of the strategy, we are thinking in general environments. But in engineering, the environments are very particular, and in this case is related to the representation of the solution as a matrix, and this matrix has properties that later are used to form the rigidity, the stiffness matrix used in a finite element approach, for example. So the diagonals has to do with some points, some particular points of the structure in general, and you can analyze these segments of this representation and use it for your advantage in the optimization process. And this advantage is that you can control where are the rigid, the stiffer elements, and you can use it in your advantage. Well, in the algorithm advantage, if you manage to make the algorithm to detect where are the critical elements that control the optimal shape, no? And you can also deal with these elements in the sense of stresses, because you can detect that the elements that control the resistance of the structure probably are related with the elements that are the more expensive or the more rigid, no? And then you can manage this representation to modify a particular element or several elements that affect the behavior of the solutions, but not in a single manner. You can control it in the swarm or in the group of individuals. You know? And then if you take these validations problems, we found that there is a chance, there is an opportunity to find novel solutions even in well-studied problems, because if you control the exploration space with a number of elements that move efficiently in this space, you can manage to explore some regions that haven't been explored before. And this exploration capacity also managed to find solutions in a very rapid manner. Like here I am showing you. As you can see, well, I wanted to show you something that I found particularly interesting, that if you see this blue line and this red line, the red line represents the penalization of the solution, of the best solution in the round, and the blue line represents the best solution value of the line. And these two lines are getting closer together, and they join in a certain point where the solution is not penalized and the individual can be built in the real manner. And it is interesting because the solution is evolving from a bad solution that is penalized. It is not the best solution, and gets to a point that the solution is near the best, and it is not penalized in a very quick, in a very early point of the iteration process. And then it is also consistent in the behavior of another type of problem, that is a problem that has no limits in the bars that can be used, and it has no limits in the points that you can use. And this approach and this problem approach to a well-known solution, also in very few iterations. So, and as a final comments, I would like to ask that the importance of the boundary conditions are kind of how to say, it has to be very well defined in an optimization approach, because in an engineering problem, it is very difficult to define sorry for this. It is very difficult to define a region that could be close to the optimal global solution. So the boundaries are the limits that define these regions. So there is a need of experience of the engineer to know how what these limits could be. So it is like one of the main characteristics that limits a mathematical efficiently algorithm to be put in the context of an engineering problem, and also related to a real solution. Yeah, and also these limits are related to the novelty of an emerging solution, because if these limits are very narrow and are very close to what we know in engineering, we probably won't find a solution that will break the box of the context of an engineering problem. So it is important to have a balance of these limits, not to put it very narrow, but not to put it very wide, because if you put it very wide, you probably won't find an optimal solution. So, and also you will be dealing to how to say an area of problems that will we always growing in complexity, and it is also kind of a how to say kind of a well kind of discouraging for someone that is working in this area, because you won't have an end in the sense of the knowledge that you will have, because the problems will be getting harder, and the tools that you will be getting will be almost infinite as the solution you will find. So I think I am on time. You can stop me. This will be my last my last image.
Okay, tell me one thing. What is the source of your data for iterations?
Okay. The source of the data is at the beginning is a random solution algorithm that generates random points of the geometry and random cross section for the elements, and a variety of several. Sorry, I'm gonna start again. The source of the data is a random algorithm that generates random solutions that varies in number of nodes and varies on number of elements that connect each node, and each element also can vary in cross sections in the geometry of the bar that you can use, and this solution, these random solutions, evolves until a particular solution.
Okay, thank you so much for the presentation.
Thank you.
And now we'll move forward to our next presenter. And I would like to invite Yogesh N. Patil to present his paper on the title, A Small-Scale Ontology to Represent Knowledge About Question Item. Dear presenter, you may please start your presentation.
Am I audible?
Yes, you are audible.
Yeah. So, thank you, SMARTCOM, for giving me an opportunity in order to present my paper. The topic of my paper is a small-scale ontology to represent knowledge about question items. Normally, ontology as a branch of philosophy seeks the classification and explanation of entities. Basically, this paper presents an ontology to represent the knowledge associated with question items. As we all know that pre-COVID, COVID and post-COVID, the way the examinations are getting conducted has been totally changed. The manual approach has been taken over by e-learning sort of an approach, and even the way the examinations are conducted, even in examination, it's an e-examination sorts of approach that has come forward. But the question that arises was that the type of quality that we used to have may or may not have as far as manual system was concerned, whether the same sort of a quality that we are supposed to have it in an e-examination system or not. So that is where I am going to present a small scale ontology. The ontology is described through UML notation and is practical and sufficient in expressing various properties related to question items. Ontology's primary application include designing question banks and generating question paper based on constants such as graded topic coverage, broad question types, multiple difficulty levels, and rules. So these are
Hello, your slides are not on the screen.
slides are not on the screen. Now,
No.
sir?
No. Yes, yes.
Yeah. So an examination is an evaluation and assessment process normally. And there are, as such, any examination system or any examination process include two activities. One is a data intensive activity, and the second one is a knowledge intensive activity. Now, as far as data intensity activity is concerned, there are issues related with examination forms to distribute hall tickets and to issue admit cards for examinations are some of the examples of data intensive activity. Now, as far as knowledge intensive activities are concerned, designing a question paper and to evaluate answer books are knowledge intensive activity. Now, as far as data intensive activities are concerned, in data intensive processing activities, the main focus of an application is to store the data, to retrieve the data, to update the data, and to generate various kinds of reports. But as far as knowledge intensive activity is concerned, the input information is analyzed from various dimensions. New information is synthesized, and the synthesized information is presented in multiple forms. So that is what the main approach as far as knowledge intensive approach is concerned. Here we are focusing on one of the knowledge processing tasks, that is how to represent the knowledge about question item so that it can be utilized to automate the process of question bank generation. Normally here we are using something in the form of a service oriented architecture, which is currently being used as a preferred technology to develop and deploy e-learning application. So obviously the motivation is to represent the knowledge associated with question items using ontology and expressing various properties related to question items. Obviously, to capture the metadata, see, at the end of the day, when it comes to a knowledge, it's not only the question item that is going to play a crucial role, but along with the question item, how exactly the metadata that is related with that particular question item that is going to play a crucial role. And as far as Bloom taxonomy is concerned, we know that there are some 5-6 features that has been specified as far as Bloom's taxonomy is concerned. So these features should play a crucial role, and that is where the metadata is going to play an important role. The primary application include designing question banks and generating question papers based on this particular constraint. The scope of the question ontology. See, to support the activity of generating the question papers for standardized examination system, hence the design of the ontology reflects the requirement and issues that need to be addressed in such a system. The main challenge experienced in such a system is to improve the reusability of question bank, because it's not that it's one time that we are going to have a question bank, and from that question bank we are going to generate some sort of a question paper. But such a sort of a question bank should be in a reusable fashion. So whenever we will be requiring it, whenever we want to generate some sort of a question paper, we should be able to generate it. The secondary goal is to develop a common understanding of the meaning of the properties to require to describe the question item. And this secondary goal has to play a very crucial role, because that is where what exactly that particular question item is, what are the features that makes up that particular question item, and what are the constraints that should get imposed on it when you are going to generate something in the form of a question item that becomes a part of a question paper. Roles in university examination system. There are various types of roles observed in the manual and computer associated testing system. Those roles are defined by keeping. So I will show it to you with the help of the UML notation. See, this is what the manual examination system is, and this is where we are moving toward e-testing system. So as I mentioned that prior to COVID, things were different, but after COVID, when we were in COVID, we had moved towards this e-testing system. And in both the places, the center of attraction was obviously the question items. These roles are defined by keeping at the center of how various roles interact. In manual testing, you'll find that the paper setter plays in manual system, you'll find that that the paper setter, since actually it has been injured, this is what the manual examination system is, and this is what actually the e-testing system is. You'll find that the paper setter plays the primary role. The question paper setter is responsible for selecting the question item that will evaluate at students' knowledge and skill. That is, for example, something in the form of a numerical problem solving skills, analytical skill, design skills, etc. that has to be acquired by following prescribed curriculum. Now, as far as the e-testing system is concerned, or as far as the traditional manual paper setting activity is heavily dependent on a subject matter expert. So this is going to play a very crucial role as far as this particular system is concerned. Usually it is assumed that the paper setter are aware of the student psychology and assess different kinds of skill acquired by them. Identifying such subject matter experts is one of the challenges that need to be addressed in manual paper setting activities. The other subsidiaries of this particular system is something in the form of the examiners who is going to grade the question item, the proofreader who is going to validate it, the candidate is going to respond to each one of that particular question item, and obviously the invigilator is going to deliver it. Now, as far as e-learning system is concerned, the test creator, see here, this is the test creator, is an automated system, plays the role of paper setter from the manual method. Whereas the role specific here, the role specific are something in the form of the authoring system as well as the interbank manager. Now the authoring system will be responsible for creation of question bank, whereas the interbank manager will be responsible for management of question item. Both present only in automated system, which are not present as far as the manual system is concerned. One of the difficulty often faced while finding an appropriate question item from a question bank is that the question items are inadequately described with proper metadata. Other challenges that recurs frequently is automating the process of generating the question papers that satisfy multiple constraints such as uniform topic coverage and coverage of various kinds of skill. Further, in many e-learning platforms, the functionality and associating multimedia content such as the images, the graph, the audio, the sounds, etc., classification categories and information regarding the topic or subject topic to which question item belongs is missing. The educational institutes and testing authorities can address these challenges by defining an ontology for these particular question items. So this is what the question item ontology that has been presented. The ontology presented has potential application to design a comprehensive and well-organized question bank. And again, at the center, you will find the role that is going to be played. It will be obviously by question item, and there are some subsidiaries role that will get played here. And well-organized and question bank and generate examination paper based on various constraints such as graded topic coverage, broad question type, multiple levels of difficulty, and similarly such constraint. The purpose of this premises is to assert explicit assumption that we make while designing question item ontology and application around it. The significant concept identified from this postulate include question bank, question item, the course, the skills, the examinations, the grading rubric, the author's response, and the question body. So these are the subsidiaries that are going to play a crucial role. The question item belongs to the course. The question item evaluate the skill. The question items appears in an examination. The question item is graded through the grading rubric that has been specified in the Bloom's taxonomy, is designed by some sort of an author, and the question item is definitely going to has a response from the student who is going to appear for the examination. The question item is supposed to have a question body, and that is where your ontology is going to play a very crucial role, and that is where the metadata that has been specified for that particular question item is going to play a very crucial role. See, this is what the UML representation for question ontology. Because
sorry to interrupt, but sir, please conclude your presentation.
Yeah. So this is what the major model as far as a question item is concerned, and you'll find that every metadata that is necessary as far as a question item is concerned has been specified here. So for every question, you need something in the form of a supplementary information, that is whether you need something in the form of a map or a table or a figure or a graph. Then, as I mentioned, the Bloom's taxonomy is cognitive domain, the knowledge, the comprehension, the application, the analysis, synthesis, whether that particular question belongs to what particular unit, then from that particular unit, what particular topic, and from that particular topic, what subtopic, then whether that particular question will be of a short question type or a true false type or a descriptive or a multiple choice or matching. So in this particular fashion, the entire ontology has been specified, and which helps you in order to specify that for every question you do specify the metadata, and that metadata at the end of the day is going to help you in order to generate a question paper from the question bank. So I will come to the conclusion. It's described the motivation behind developing a small scale ontology for describing question items. It also describes a small scale yet sufficient to design question item centric application in the e-testing environment, include a wide range of properties to capture all aspects of question answer as has been specified in the last diagram, to generate the template for examination and assess the quality of software exam. Researchers can design of the potential application based on this. Thank you.
Okay, next part, presenter.
Okay, Professor Yogesh Patil, thank you so much for your presentation.
Yeah, thank you.
And now we will move further to our next presenter. And I would like to invite Arvind Prakash Senthil to present his paper on the title Design Analysis and Optimization of Changes for Mobile Robotic Platform for Supermarkets. Dear presenter, you may please start your presentation.
Good morning, all. Is my screen visible?
Yes, it's visible.
Yeah, okay. So I'm Arvind Prakash, and today I'm going to present the paper on design analysis and optimization of chases for a mobile robotic platform, which is used for supermarkets. So this in supermarkets, if we see, there will be narrow spaces between each shelf. So this makes it difficult for customers to navigate between them. Also, during rush hours, the majority of the bill counters are completely occupied. So this makes people disinterested towards the purchasing. And unlike online shopping, offline shopping allows people to interact with the items they are purchasing. So this can be accomplished with the smart trolley that is compact and has a high payload to weight ratio and includes a billing machine within it. So the design of this compact trolley chases is discussed in this paper, and different cross sections of the structural members are compared to determine which one has the highest stiffness to carry the load. Different materials are subjected to static and structural analysis. Various materials are selected using Ashby charts to determine the best material for the application. And parameters known as material index or performance index is also used to find the material. Next is to avoid resonance of the chases, which may cause the failure, breakdown of the trolley part. The modal analysis has also been carried out. So the main problem statement would be to design a reliable, compact, and adaptive trolley system. Then suitable material that is chosen, like around 5 to 6 material is chosen based on the Ashby chart material index, and the trolley is also subjected to the analysis to avoid resonance. So the methodology is as follows. The free body diagram of the entire trolley cart system is analyzed, and the reaction force is also calculated. Then the cross section is selected based on the area moment of inertia of the tubes. Then the design of the chases is carried out in SolidWorks software, and calculating the material performance index is also done. The material which has the lowest material index is chosen as the best material for the application, and dimension optimization is then carried out in SolidWorks software itself to find the best dimensions for the trolley that can navigate through the narrow spaces. Next, model analysis is carried out. So this shows, this is a free body diagram of the trolley structure. So this is the side view of the trolley, and we can see we are taking moment about the point R1. So from there we are calculating the reaction forces on each wheel. And after that, through the calculation, we found that the R1 is 125 Newton and R2 is 131 Newton. Where the similar results were also given in the SolidWorks software, which is shown in the top right corner of the slide. So next is the cross-section selection of the tubes. So if we see, we have taken 4 cross-section of the tubes, which represent the skeleton of the trolley structure. The first one is a hollow square tubes, which has a moment of inertia of 7,872 mm/4. So this table lists all other values of those cross sections. So from this, we can see that the profile tubes has the maximum moment of inertia, which means it has the most hollow square tubes has the highest value, which means it is more stronger than any other material. So next is the finite element analysis. This analysis was carried out in SolidWorks analysis software itself. So the boundary conditions which were given was a uniform distributed load of 490 Newton per meter and a point load of 60.566 Newton. And to find the mesh convergence, we have taken 3 iterations to converge the mesh sizes. So next is the material. The bottom table shows the materials we have chosen for the application. So these are the FEA results and discussion for the chassis structure. So we can see that the stress is around 15.99, maximum stress is around 15.99 Newton per meter square. So this is way below the yield strength of the material, and it has a factor of safety is within the limits, and the deformation is around 0.3 mm. So next is we are going to calculate the performance index. It is also called as a material index. So we considered each beam as a uniformly distributed load, and we are calculating the maximum deflection using the formula shown in the slide. And then we are finally finding the ratio called rho by sigma, which is density by stress. This ratio is called as the material index. And we are calculating this value for every 5 materials which we chosen using Ashby charts. And we are also considering cost factor. These cost data were taken from the local vendor in the nearby place. And then we are calculating the performance index, which also includes the cost factor. So next we are next thing is we done the dimension optimization. So in this optimization, we considered the values of the tube dimensions as shown in this table and the tube thickness as shown in this table itself. And then we are inputting these values into the SolidWorks software and we are setting the target that the deformation should be less than 0.5 mm. So the found optimal value of the length and the tube thickness is 20 mm and 2 mm respectively. Next is the model analysis. In this model analysis, we gave the boundary condition like bottom corner of the chassis is fixed. And then we are calculating the natural frequency, first 6 natural frequencies of the structure. So these 6 natural frequencies are listed in the table in the left-hand side. And then we are calculating the motor speed, and using that, we are calculating the disturbance frequency, which tells how many times the trolley is oscillating due to the disturbance it's going to travel on. So we can see like we have obtained 3.3 hertz, and which is less than the first natural frequency. So here the resonance has been avoided. So to conclude, compact frame chassis was designed in SolidWorks, and the reaction force were calculated, and it also was evaluated using the SolidWorks software. And material with the lowest material index was found to be armate fiber when the cost is not considered. And whereas if the cost was considered, the aluminum 6061T6 would be the optimal material to go for. And regarding dimension optimization, we found that the length of 20 mm and tube thickness of 2 mm was more suitable for the said application. And model analysis was carried out and the resonance was avoided. So these are the references which are taken. And thank you. Any questions?
No, good presentation. Next.
Okay, thank you.
Okay, thank you so much for the presentation. And moving further, I would like to invite our next presenter, Nitin B. Ghatge, to present his paper on the title, Evolving Time Series Data Streams, a Review. So dear presenter, you can please start your presentation.
Thank you, Anisha. Am I audible?
Yes, you're audible.
Okay, let me share my screen. Is my screen visible?
Yes, it's visible.
Thank you. Good morning, all. I'm Nitin Ghatke, and today I'm going to present my paper, Evolving Time Series Data Stream, a review. So what is the time series? And as we know, after the COVID, like everyone want to go to the digitization, right? So any business, any medical field or anywhere, how we can predict for the time series data. So currently there is a lot of challenges with the time series data when you do the predictions. Okay, so time series data keep evolving, keep changing his pattern, right? So for example, as I say, applications in financials or the domain, business domain, for example, like a stock market, like regulatory or the settlement, reconciliation, same way on the householding, like electricity or weather or the medical domain, for example, EEG. So all these kind of the application where the data is the time series data. And as I said, time series data is keep evolving, and the main characteristic or the concerns with the time series data is like volume is always high. Or any use case, any application in time series, volume is always high, and the frequency is like hourly or daily or weekly. That's the another like characteristic, and the it keep like evolving. And the biggest concern with the time series data, as I say, volume is very high and concept drift is start coming. So for example, if you have the use case and you take the historical data, you train your model, and models start predicting with suppose like 80% accuracy. But when the data get evolved, pattern get changed, definitely your model will not support that. And then it will drop the accuracy of the prediction, which will result into the wrong decision of the business and result into the high losses to the business, right? So that's the main concern with the time series data. And there are different kind of the drift actually we see in the time series data. Like there's a sudden drift, for example, like in the COVID, the stock market suddenly gone down, right? So that is called like a sudden drift, where they like a gradual drift. Gradual is like the shops or grocery shops slowly, gradually moving to the malls now, right? Then incremental drift or reoccurring drift. So reoccurring is like crackers get sell more during the Diwali festival. So it's a reoccurring drift. So there are the different kind of the drift come into the time series, and how these models will actually react to those drifts and adopt those changes. So currently, I have gone through multiple papers, and the biggest problem with the time series data is when the drift get occurred in the time series data, models stop performing with the best accuracy, accuracy get dropped, and it result, as I said, into the losses. Business users have to face to the losses, go back to the developers, retrain the models. It takes a lot of time. So how we can do that? For the time series application, we come up with, like, if we put everything into the one umbrella, as I say, volume of the time series is very, very high. So every time if you return, it will take a lot of time. So first is like a lightweight. So can we do the lightweight instead of uh, considering all the data for the pre-processing, only take the samples and do that. So that is the lightweight. Concept drift online rather than waiting for the business process. The concept drift will detected online, and those concept drift detected will be adopted by our model online to maintain the accuracy and reduce the losses. So this is the ideal forecasting model for the time series data, which is not existing anywhere now. So different methods which we are proposing. So we have gone through the existing many literature reviews or the research papers. So for example, like lightweight. So I have gone through those papers. Some papers, they are using the segmentation. Some paper, they are using the stratification. Stratification is nothing but like actually they are dividing or splitting those time series into the smaller series and calling like any other technique or like a hashing technique using, and they are actually get parallelly processed. Or the segmentation, again in these papers, they like paper number 6, they say like they are splitting the time series before modeling. So they are the different segment divided into the different data sets, and each model or each segment will parallelly process. Or in some paper they are saying like feature selections. Okay, so in some papers they are talking about the window based models. So there are the different papers, but actually when this is a very, very key element to identify the right data to for modeling, because if you have the good data quality, right sample of the data, it will give the better prediction. So what we are proposing here, like segmentation plus selection, if we combine together and give the best quality data to predict better. Then we gone to the many papers for the detecting drift. So actually in the detecting drift, they are using like a windows basically. So like for example, paper 1, they are using the OASW, which is like optimized adaptive and sliding windows. So they have a one fixed sliding window which will get compare their results with their thresholds or the previous model. While in paper 2, they are talking about Adwin, which is the adopting window. Here they have the two sliding windows basically. So one is a fixed window, one is the sliding window, and the sliding window results get compared with the fixed window. And whenever there is the difference against the threshold, they are saying like a drift is detected. So same way in paper 6 also, they are talking about the what is the new data most similar like a segment from segmented data. Okay, so here also they are talking about the windows basically. Same way papers 9, paper 16, paper 19, they are using the different technique to detect the drift. While in paper 19 they are talking why to detect the drift. Whenever the new data points come in, you retrain the model again and again. Actually this will take a lot of time, accuracy will drop. So actually in our proposed methodology, we are proposing a two slide like a window, one fixed and one sliding, having the fixed length of W, and whenever there is a drift compared to the threshold value, the way we are doing the threshold value is you have the 100% data, 80% data on which your model gets trained, and 20% data it will get validated. So whatever the results you will get, we have to put some constant number because that will be too accurate. So we are putting 20% constant, and that will be our threshold value. So any value comes less than the threshold value during that sliding window, then we say like a drift is detected. Same way for the adoption of this concept drift. There are many papers, actually most of the papers are talking about the simple solution. They are actually taking one of the use case and they are saying like, okay, this algorithm will be the best algorithm for this kind of the use case. Or some papers they are talking, okay, they are comparing couple of algorithm and saying, oh, another algorithm is the best. In some papers they are talking about customization of some algorithms or mixing of some, not customization, mixing of some algorithms and providing the results. So these are the different, but these are the different people. What we are proposing, like if you look at the research gap, major gap is there is no end-to-end holistic solution which will actually do the fast pre-processing, adopt like detecting the concept drift and adopting those changes online to ensure the accuracy is not dropped. So there is many gaps in this research which we are proposing in one holistic view: the lightweight data set, drift detection, and online adoption. So these are like three methods, as we say: lightweight method, change detection methods, and effective RNN method. So these are like a different method we can talk about here. In lightweight, as I say, we can use the feature selection and segmentation to get the best quality data. In change detection, we'll use the sliding window method with the threshold to compare and detect the drift. And in adaptive, when like concept drift is detected, we'll retrain our RNN model, which is like a recurring neural network model. And while retraining is done, using the last W data instance to add a new learning to the model without forgetting the already learned concept. So we are not going to use complete data while retraining. We are going to use the last window of size W, which will learn the model and not forget the existing thing. So it will be fast processing. Okay, so this is the model what we are proposing. This is a kind of like architecture diagram, as I say, like different sources will be there. Then how we are going to pre-processing, how these are going to online adapting the changes, and then execution and deploying. So finally, as I said, a conclusion, there are many problems, and upcoming years you will see there's a lot of future or scope for the data science or this kind of the models. And for the business users, to avoid the losses in any kind of the time series uses, we are going to research on the robust model which will do the end-to-end lightweight detecting concept drift and adopting changes online itself. And as I say, it's not specific to one use cases, but it will be used for any kind of the use cases. And these are the references. Actually, I have gone through the detailed paper, what data sets they use, what is the business problem they're talking about, which model they use, and what is actually what I'm proposing and what is the gap actually. So detail come up reference. This is the review for evolving time series data. Definitely it will add a lot of value. Sure, like a best processing and give the best outcome to the business. So thank you. This is the end of my presentation. Any questions, please? Bharat sir?
No, next question and next presenter.
Okay, thank you, sir. Thanks for
Very good presentation is your.
Thank you, sir. Thank you, sir.
Okay, thank you so much for the presentation.
Thank you, Anisha.
And moving further, I would like to invite our next presenter, Vishal Mehta, to present his paper on the paper title, Identification of Cracks in High-Rise Buildings Using Drones and Deep Learning. So, dear presenter, you may please start your presentation.
Hello, is my screen visible now?
No, it is not visible.
Madam, you call presenter till he will prepare.
Okay.
Okay, sir. Okay, so we're moving on further to our next presenter, and I would like to invite Lubna Ansari to present her paper on the title Innovation Task Scheduling and Allocation Algorithm for E-Governance with Multi-Cloud Environment. So dear presenter, you may please start your presentation.
Okay, hello everyone.
Yes.
I hope my screen is visible.
Yes, it's visible.
Okay, great. Thank you so much. All right. So good morning, everyone. My name is Lubna Ansari, and today I'm going to present a paper which is on innovative task scheduling and allocation algorithm for e-governance with multi-cloud environment. So the topics that I'm going to cover in this session would be introduction, multi-cloud, literature survey, why normalization is necessary, my proposal algorithm, in conclusion, and references. So first of all, what is cloud computing? I think we all are aware of it. So cloud computing is a new yet popular phrase bloomed in location all over the world. Okay, now in a simpler language, how can we define it? So we can say that cloud computing is the delivery of cloud computing services, which is include servers, storage, databases, networking, software, analytics, intelligence over the internet to offer faster innovation, flexible resources, and economies of scale. Okay, so we are using cloud computing in every area, and e-governance is also there. So if we use e-governance with the cloud computing, we can see the result. Okay, so e-governance combined with cloud computing makes it easier to implement integrated policies and public services that support long-term economic growth, social development, and environment preservation. So again, the term is multi-cloud. Now, what is a multi-cloud? So multi-cloud means multiple public cloud. So generally, if a single cloud, we have a single vendor, but in multi-cloud, we have multiple vendors. So instead of a business using one vendor for the cloud hosting, storage, and full application stack, in a multi-cloud configuration, we have several. Multi-cloud deployment have a number of uses, like we can have multiple IaaS vendors or PaaS vendors or SaaS vendors. Then because of the time constraint, I'm just referring to three of my paper. So first paper was Ang, and he actually developed a dynamic pricing model in their study. Okay, adjusting the price by enhancing the use of underutilized resources while discouraging the use of overutilized resources. Now, while doing this research, he actually conduct this on the data intensive and compute intensive activities. Data intensive means the user only asks for some data. Right. For example, in a hospital, a user is actually asking about whether this doctor is available, only data intensive. In compute, when we have to do some computation on the cloud. Another one is by Mishra, and he actually established ETAMCN, that is energy aware task allocation in multi-cloud network. Okay. The next paper is actually by Sanjay Panda, and he actually proposed three algorithm, MCC, which is minimum completion cloud scheduling, which finds the completion time of the ready task on each cloud. The completion time for task is the sum of the expected computation time of the task and the cloud ready time. That means the cloud is ready to take the task. That is the cloud ready time. And the next one is MEMAX, which is the median maximum time. It is a two-phase algorithm. In this, the first, it calculates the median execution time of all the ready tasks over all the clouds, and then it selects the task which has the maximum median value and assign it to the cloud, and the cloud can actually process it. And then finally, we have CMMN, which is cloud min-max normalization. This is again a two-phase scheduling. Here we do the normalization and then we could do the scheduling. Now, why normalization is necessary? See, normalization is a process of transforming a set of values into a specific range, say from 0 to 1, right? Now, it is used to scale the data of an attribute so that it falls in a smaller range. Now, when a task comes, the execution time of a particular task may be it takes only 1 nanosecond, someone take 100 nanoseconds, someone take 1000 nanoseconds, right? So in that case, the data is actually, the variation is very large. So we have to scale down a bit. And that is the reason we are using normalization. So when multiple attributes are having values on different scale, this may lead to poor data models for data mining operation. So they are normalized to bring all the attributes on the same scale. There are 3 popular ways of normalization, which is decimal scaling, min-max normalization, and Z-score normalization. So here in our algorithm, I'm using Z-score and decimal scaling normalization. Now, our proposed algorithm is the cloud data center may not have a limitless capacity to provide the requested service during the peak hours. So what we are doing, we are actually using multi-cloud. Okay, now in the multi-cloud, the resources can fulfill, the request can be fulfilled by the resources which are present in public, private, and the hybrid cloud, and it is referred to as a multi-cloud. Clouds must be diverse, since having varied formal properties and capabilities. Workload allocation across various clouds is difficult and poorly understood. So we need to do develop this job scheduling algorithm in multi-cloud. So in this research, as I mentioned earlier, we are using ZTSCN. What is this? Z-score decimal scaling clouding normalization. It's an optimal task scheduling technique with normalization for scheduling heterogeneous multi-cloud environment. The methods are based on classic normalizing approaches, specifically decimal scaling and Z-score. Now, here we are actually assuming 2 kinds of tasks that will come to the cloud. Okay, it could be best efforts and advanced reservation. Best effort, these are the jobs on their arrival are provided with the required resources is available. Else, they are required for the fulfillment of their requirements with the resources will be available. For example, a task is come and the resources are not there. So that task will go to the ready queue. Sorry, the waiting queue, and when the resources are available, it will be executed. Then we have advanced reservation. Resources are reserved in advance for this type of job. Resources are expected to be available at the specific time when the job arrives. Now, we have more priority given to AR task than to BE task. So execution of a task in AR mode may preempt a BE task. If a BE task is preempted from a cloud, say CI, due to the arrival of AR task, then it must be executed only on the cloud CI immediately after the AR task is over. Now, the primary function of the proposed model is to distribute the workload across the cloud in such a way that reduce the overall make span. Make span is basically the execution. Now, what we are doing here, we are taking n task, okay, n number of tasks, and the timing of the task to be completed and the method of this submission, that is, it is AR task or a BE task. Then we have m number of clouds also, and the duration of each job execution in each cloud is given. Okay, now this is what we call ETC metrics, that is estimated time to compute metrics. Okay. Now, each AI application has a unique time of arrival and is published for cloud provider in one of the modes as BE or AR. Okay. Now, a job doesn't begin until every preceding job has been performed. Okay. Now, let's say we have ETC IJK, which means that it is the time taken by the jth task of the ith request on the cloud team. See, we have a user request, then it is further distributing into various tasks. So I'm saying here that by the time taken by the jth task of the request I to execute in the K cloud. Now, the challenge of the task scheduling given an ETC matrix is to allocate all the tasks to the cloud such that the tasks are executing, fulfilling their precedence with the objective to minimize the make span of the entire set of application. Okay. Now, again, as I mentioned that we have different execution times, so we need to normalize it. So we normalize the ETC matrix in the first step to obtain the normalized ETC. Okay, then which is used for the next step. How we are doing it? We are using this ETC. Okay, so the matrix of ETC, that is normalized ETC, NTC, IJK, it is actually ETC IJK minus mu IJ by sigma. Mu is actually the standard deviation, sigma is actually the mean. Sorry, mu is actually the mean, and sigma is actually the standard deviation. If we make this normalized ETC, then if we actually add up all these tasks, then it will be equal to 0. Okay, so now Z-score can be applied for both offline and the online scheduling. However, it needs to recalculate the mu and the sigma values to normalize the edit task in a non-uniform manner. Now comes the allocation. Now we have the task, okay, and we are actually sorted them, the large set and the small text set. Okay, now we have to allocate the VM machine to each task. How we are going to do this? We are actually seeing that where it will fit and where it will execute it more appropriately. So following the summation of a sequence of tasks for the task queue, a judgment is made in all the tasks based on a scheduling algorithm to determine if the performance offered by the virtual machine matches the task minimum criteria. Right, now suppose we have a task and then we have T1, TI1, TI2, TI3, TI4, TI5. They denote the task of task TI for CPU, RAM, bandwidth, disk, and reliability requirements. Similarly, we also have VKJ. It denotes the jth VM of the cloud CK. Now here, VKJ denote the resource attributes of the VKJ virtual machine. These are all the attributes. Okay, again, CPU, RAM, bandwidth, disk, and reliability. Now, for a given TI and VKJ, we have all the attributes of that task, and what is the security demand, that is TIST. Then TIWS is actually the workload, and then we have VKJ, all the attributes of that virtual machine, then the processing capability of that virtual machine, that is CPKJ, and what is the computing cost of that virtual machine, that is CCKJ. Now we actually have a function. Now, if the security level is greater than or equal to of the task security demand, then the value is 1. Okay, the security given or provided by the virtual machine, it is greater than or equal to, then we will actually assign the task to that virtual machine. Otherwise, we will reconsider it. And then what we will do, we need to make the match between the task requirement and the resource attributes in order to meet the performance, quality of service requirements of the user as best as possible without causing a waste of resources. How are we going to do this? We are actually using the probability, Bayesian probability. Now, to make the resources best meet the demand of the task TI, it is necessary to obtain a relationship between the task requirement and the resource attributes of each virtual machine type, and the probability that the task could be assigned to each type of the resource. So as I mentioned, there are 5 attributes: CPU, RAM, bandwidth, disk, and reliability. Okay. And there are D types of virtual machine in the multi-cloud. So let YD denote the virtual type, D in a multi-cloud. Okay. YD is, again, we have YD1, YD2 denote the aforementioned 5 resources attributes of the YD. This is how we actually going to calculate the probability. So Bayesian probability is adopted to calculate the likelihood that TI matches with the YD, which is denoted by PYD given TI. And the conditional probability of each feature attribute under each category is obtained. Okay, then we have sigma J, it's denote the VM type of type number of VJ. Okay, this is how we calculate the probability. Now, because the Bayes theorem states that all the feature attributes are conditionally independent, like CPU, RAM, and every attribute is actually independent. So what we are doing, this P of TI given YD multiplied by YD is nothing but P of TI1 given Y, P of TI2 given Y, and so on. Suppose we have 5 attributes, of it is 5, or 4 attributes is 4. So this is PYD given TI is actually equal to PYD sigma, pi from alpha 1 to 4, the number of attributes that is from 1 to 4, and then we calculate the T probability of T given YD divided by PTI. Now this actually, this PYD by PTI, it's constant, so we actually taking where sigma for the this. So let's say the sigma, where sigma is actually equal to PYD given PTI, so the probability will be equal to sigma into pi from alpha 1 to 4, probability Ti and B and delta J. So the bigger
sorry for the interruption, but ma'am, can you please conclude your presentation?
Yes, sorry. So, all right. So this is a predictive thing that my algorithm, our algorithm, ZTSCN algorithm, it is actually better than all the given algorithm discussed by Sanjay Pandya. Okay, and these are the references. Okay, thank you so much. Any question?
No question.
Okay, thank you so much for the presentation. And
Yeah,
now,
Hello.
yes, Vishak, you can
Yeah.
present your paper now.
Okay. So can you see my screen now?
Yes, it is visible now.
Okay, thank you. So my paper is identification of cracks in high-rise buildings using drones and deep learning. Uh, so the conventional way of identifying structural defects in high-rise buildings is requires a lot of manual labor, scaffolding, and um, it is very time intensive. Lot of nooks and crannies need to be checked for structural defects, and the whole process of the discovery part of this problem can be made much easier, which is what we propose using drones and image classification algorithms to check for structural defects in high-rise buildings. So this paper basically encapsulates some pre-trained models like VGG16, ResNet 50, exception, inception, DenseNet, and a shallow neural network, that shallow CNN that we made customized to the requirements of this particular project. So a lot of cities have a lot of buildings at the moment which need constant inspection by the local authorities, and many people have been known to abscond these things that they need to check. So the local authorities can take this task into their own hands by employing a few drones, and they can check for the structural defects themselves. uh, so what we found out in our paper, first of all, the literature survey. There have been many studies regarding this topic. Some people have used CNNs and image classification algorithms, but their accuracy has been 94%, which is considered a little less. uh, some people have achieved 99.39% accuracy, but their training took 8 hours, and every time to check it, they had to train the whole model again, which is not good. And they achieved it at the 13,000th iteration. We were hoping to aim it at a much lesser computationally expensive uh, cost. And some people have used Google Lanet and also principal component analysis to make the predictions. Um, People have also done these studies on pavements and masonry surfaces. Uh, and there have been many papers which uh, compare the accuracies of these pre-trained models like VGG, ResNet, AlexNet. but they have achieved an accuracy of 95.5%, 96.9%, and as such, we were hoping to enhance these using filtering and various other pre-processing methods. So our proposed system was a drone will first fly to the height of the building and capture images of any structural defects, basically making a 3D structure in images, and then we will inspect all of these images using our algorithm and classify these images into two classes, cracked and uncracked, and these images can then be displayed to the auditor. So to maintain the structural integrity and avoid any fatalities, manual inspection method is very tedious, as I said before, and so we proposed drones. So our implementation was we took a data set made by Middle East Technical University, which had 40,000 images and which were of good detail. Then we had SDNet 2018, which was published by Utah State University, which was it's widely recognized, but it has now dated a bit, and their images it is a very unbalanced data set. And the last one was an open source data set that was posted by a GitHub user named Kang Cheng Liu, and this data set was also worked upon by us. So we worked on 3 data sets. Apart from this, we also used our own drone to create a small data set of our own to see if these algorithms would work in real life, like on the images that we took from our own drone. So here is the comparative analysis for dataset 1. Our CNN performed at a 99.28% accuracy. And as you can see, the other pre-trained models also work very close with that. The first dataset was very detailed, that is why. The second data set, which was like less detailed, had VGG16 as a top accuracy scorer, followed by our CNN. In the previous data set also, you can see VGG16, due to its sheer strength of parameters, wins in accuracy, and it is closely followed by our CNN. So here are the evaluation metrics on dataset 2, which was the lesser defined of the two datasets. And this one is for VGG16, while this one is for our own CNN. So the drone we used was the DJI Talon Nano drone, and it has a very mediocre lens. 5 megapixel pictures are only clicked. Due to our limited budget, we could only select a less quality drone, but a full scale project we can invest in a better drone, and it can be easily controlled through a mobile, and we can create a gallery of like a test data gallery very easily. So these are the few images that we clicked in the nearby residential society and the parking lot adjacent to it. So these images, as you can see, aren't very detailed, but our algorithm still worked upon these. Now, one key point that our CNN won over the VGG, it was a little bit behind in accuracy, but while testing for false positives, as you can see, these images don't have any cracks as such, but these images have paint exfoliation. Now, this isn't a structural defect, but VGG many a times, almost half the time in such images, gave this as a positive for crack, while our own CNN only did such in 10% of the instances. So this is a crucial point of our own CNN. Here we see the accuracy. CNN gave accuracy of 99.28, and VGG is slightly better at 99.73. In the second data set, VGG has a good accuracy, but in dimly lit areas and also in identifying false positives such as exfoliated paint, CNN won over VGG by a wide margin. So in conclusion, I would say all the models were validated on standard performance indicators. VGG worked better in all the data sets, winning by a thin margin. But the custom CNN was able to detect cracks in images taken by drone with a high degree of accuracy. In the data set that we created with our own drone, CNN had a better accuracy. Even identifying false positives like exfoliated paint, the CNN won. And the CNN also trained much faster than the pre-trained models such as VGG16 because they have a lot of parameters, whilst our CNN only had four layers, and it worked on RGB filters, and the pre-processing was done by us in many ways. So our future work shall include a real-time analysis rather than working with images. Will work with video feeds directly embedded from the drone to our computer. And structural defects are not just limited to cracks. So we would like to include more points from this topic. And later on, they can be integrated with LSTM GAN models. We can generate synthetic images like taking the skeleton of a crack and permuting and combining it to produce a bigger crack gallery, and then use that. And that is it. Any questions?
One question is there. Which tool
Yes.
you use for data analysis?
For data analysis, sir, so basically we used image classification algorithms, and we used evaluation matrix. So just
No,
in
tool. You actually feed data and find the results, or only theoretical results are there?
No, theoretical results are there, as well as we used our own drone images, and after the model was trained, we predicted it on our own images.
No, you use you put some data in for analysis.
Yes.
Which tool you use? Yeah,
Sir,
which software you use?
Sir, in Google Colab, we used the Keras library, which has all the pre-trained models, and our own CNN also. Our own CNN was created in Python by us.
Okay.
Yes, sir. Okay, thank you.
Anisha, you are talking on mute.
Sorry for that. Yes, so I would like to invite our next presenter, Raghavendra B. Marutha Babu, to present his paper on the title, IoT-based hyper-redundant robot for generating various snake gait. So, dear presenter, you may please start your presentation.
The screen is visible. The screen is visible.
Yes.
Good morning to everyone. Myself, Raghavendra. In this conference, I am going to present IoT-based hyper-redundant robot for generating various snake gait. Introduction. Actually, a hyper-redundant robot is a robot with many number of actuators attached parallelly with the yaw and pitch joints with alternative positions, where the structure gives us the very large kinematic redundancy, and the operation will be looking similar to the elephant trunk and the snake biological snakes motions. Actually, the control part of the robot increases as the number of actuator increases. As there are many in related works I mentioned, there are a lot of proposed ways for controlling hyper-redundant robot. But the complexity of controlling the hyper-redundant robot also increases as the number of actuators increases. And I have told about the best part of controlling a robot through IoT. The problem statement is to bring a simple solution to control a complex mechanical structure like a hyper-redundant robot, and to bring a real-time communication thread more compared to non-real-time communication in a robotic system, and to control a robot through an IoT. And system architecture-wise, the whole component is divided into 4 parts: actuator, controller, and communication. Controller, communication, and user interface. The figure 1 represents the system architecture. The ID1, ID2 represents the actuator number of each motor. Around 12 actuators have been used. The power source to this 12 actuator is coming from the power source part and power source part, where the signals would be coming from the node MCU. The node MCU will be controlled using mobile app. This is the architecture we have proposed. This node MCU will be using TX pen to send the signal to the actuators. Actually, the communication part we have been using in half duplex communication. Half duplex communication is something where TX, RX simultaneously it won't communicate. Initially it can send or receive. A single work only can be done. The dependency on the IoT makes the whole controller simpler. In implementation wise, the actuator used is Dynamics AX12A. Around 12 actuator has been used. They are attached parallelly on another with pitch positions. As the weight of each actuator is 54.6 grams. Around for 12 actuator will be around 655 grams. The running degree freedom of this actuator is 0 to 300 degrees. The whole operation is done in the baud rate of 1 million. To minimize the error. This is the implementation. This is the hardware implementation I have implemented, where I could be able to see the power source will be coming from here, and the signal part will be coming from the node MCU. In software setup base, I have used the Arduino IDE to write the code for node MCU, and I inserted necessary file of dynamics configuration to the Arduino IDE. Then Blink app is used for control and communication purpose. Experimental wise, around 4 shapes are implemented in this snake robot. In this flow chart, you could be able to see a flow chart for the circle shape. Every shape controlling is similar. I have explained for circle shape. Initially, the parameters are initialized in the Arduino IDE. Then a void setup is used to set up the baud rate and the direction pin. Then initially the position value is 0, fixed as 0. 0. Then AX12A.move is a function that is used to control the robot. The input that given to the AX12A.move is IDE number of the each actuator and the position that the desired position that actuator should be reached. These are the input given to the AX12A move function. Actually, the whole flow chart written as the after completing of each IDE. After each actuator only will be passing to the next actuator. This is the whole algorithm part we written in the node MCU, where in the algorithm has 4 buttons, like V0, V1, V2, V3. Each push buttons are configured in the app. Whenever the user presses the button, that mode will be selected in the node MCU, and that algorithm will be executed. The shape algorithm are similar to each other except the position values, predefined position values. And resulted discussions, these are some sample shapes that are done to show the IoT of controlling robot is easier. Where while doing this experiment, we could be able to see the flowchart of the code is written like after completing each actuator only, one actuator only, it will be going to the another actuator. But while doing it in real time, it will be looking like a simultaneous motion of each actuator. There won't be any lag between each actuator. That is because of the baud rate we have fixed and the fastness of the IoT part. conclusion, we could see that it is very efficient and reliable and user-friendly, the IoT control system. And it shows that it's a better communication system for controlling a complex robot without any lag. In future works, we plan to do many motions like lateral undulation and linear progression using equations. Instead of keeping a fixed desired position, we can give a using equation could be able to do different motions. Then implementing inverse kinematics in the robot for the which is more better compared to the forward kinematics, and implementation of integration of AI part. That's other future works we plan to do. These are some reference I have referred. Thank you. Any questions?
Okay, thank you so much for the presentation. If any of the participants wants to ask questions to him, then they're most welcome.
No, Anisha, we're good.
Okay, so we are moving forward to our next presenter. And I would like to invite NPG Bhavani to present her paper on the title Wearable Technology with Location Tracking, Health Monitoring and Attendance Tracking for Employees. So dear presenter,
Yes,
you can start your presentation.
Yes, ma'am. Yes, ma'am. Good morning, ma'am.
Good morning.
Yes, ma'am. Can I share now? Ma'am, this is visible?
No, yet no.
This is visible or not?
Not yet.
Ma'am?
Just give it a second.
Is visible or not, ma'am?
No, it is not.
Just ma'am. Share. Now, ma'am?
Yes, now it's visible.
Okay. A very good morning, honorable present here. This is Mr. Ariel Sandi, Savita School of Engineering, Siemens in Chennai. My topic is wearable technology with the location tracking, health monitoring, and attendance tracking for the employees. So these are the abstract. A smart wearable is a fully integrated and network system. It is simply the turn of the wearable that the support environment in the area person on the article of the equipment. First of all, we have to go to the what is the wearable technology. Wearable technology is also known as a wearables, is a category of electronic devices that can be worn as accessories embedded in the clothing. So implanted in the user's body or even tattooed on the skin also. So the devices are a hand-free gadgets with a practical uses like that. So powered by the microprocessors and enhanced with the ability to send the receiver data via internet only. So where one of the more sensor the actuator nodes are located on the end user sites and many events is integrated into clothing. Nodes ability to the access a local server cloud. So they are the equipment with the motion sensor that keep daily activities, right? So the synchronous within a computers and mobile devices also. Health fitness related tracking is data is including here. So according to the identifications to wearable, the support environment in this a person or piece of cloth is also. The workers, they are the employees according to your attendance and set up the medical checkup facilities also here for them based on the report produced by the variable devices. The employee can follow the employee's wearabilities whether they are the present in the office or outside without any employees consist by using the smart wearable devices. So now we are going to the introduction. So first of all, tracking devices. Tracking devices, location tracking is wearable can help track and managing a personal in many ways, right? So for example, can minus can be attracted under the deep tuners and these are altered. If there are any signs for the distress, location can also help simplified contact tracking within a personal group in a positive can of COVID-19 is identified also like that. For the example, I said. So the usage of bioelectronic tags, brighter bags, and magnetic strips amplified the automated attendance system also. The employee touches as a swipe to provide identify using these methods. So a computer receives the offered information and the record is it, right? So utilizing the automatic attendance tracking system saves this time and decreases errors associated with the manual systems, right? So however, the automatically system are expensive. So given the widespread usage of the web application in this work, introduce the usage of the web applications for the time on attendance tracking also. So this is the architecture black diagram of the existing work. RFD, MIR as a RC5222 is nothing but it is a radio frequency identification. It's a highly integrated reader writer IC for the contents list communications at over 13.56 megahertz, right? So the MFRC 522 reader supports ISO LCE 14443, a MIFARC and N tag also. So Arduino, you know that already. What's the Arduino? It's a open hardware development board, right? So that can be used for the thickness hobbyists and makers to design and build the devices interact with the real world, right? So and open source electronic platform or board and the software used, right? So first of all, it is a black diagram of existing to work in RFST going to be Arduino and get it the attendance system as well as fingerprint go to the Arduino and get the attendance system also. And NGE GPS goes to be Arduino and get the location tracking also. Now we are going to proposed diagram. In this, all of the collaborated going to be a Arduino sections only for this RDFID and the fingerprint and NGO GPS all as a combined to go to Arduino and get the attendance system. Lastly, we have to see the web display also here the proposed work. So what is the resultant discussion here? It is a less than stressful approach to code, right? So over the years of countless of the projects, ranking for the simple household items to interact with the scientific instrumentations have used for Arduino for the brain, right? So a global community of markers, enthusiasts, professionals, students, artists, and programmers, right? So it can be congregated around this open source platform. Their contributes have a build up to a strengthening amount of the accessible acknowledgement that may be a termful assistant to both beginners and professionals. What is the futures of in this here? Real-time monitoring, tracking and certain times, task administrations, payment administrations, geofinance, and alerts like that. So this is the NPG coding uploading for the RFID MFRC, and this is the coding uploading for the RSDMA with fingerprints, right? So RFID is a radio frequency identification fingerprint sensor output is the advantage of RFID and fingerprint sensor, including the following by read and write data without a physical touch and access information simultaneously and followed by highly dependent communications and they are connected, they are a certain identity are quickly retired or electronically restored, right? So image collections tailored to single person within a cheap algorithm, professional optical technology. So reproducible for the resistant of variations of the face of outside influences, right? So going to be now conclude. This paper primarily focus on using for Arduino to tracking geolocations using latitude and longitude angles to monitoring attendance only here. And also additional pulse sensor is utilized for health monitoring system. RFID and fingerprint are used to detect the persons of the specific locations of communicate the data of the higher officials, right? So it can be detect the person's temperatures and the high headset also. Future facial recognition algorithms is image processing will use fingerprint sensor, instant or cameras, right? So face recognitions with wearable technology should be used for security purpose only here. So such as a locations, locating for a women and children and the size of should be a minimal. So these are the references here. So thank you.
Sir, do you have any questions for him?
No. This one is last one or anyone is remaining?
No, this was the last present.
Okay.
Okay, thank you.
Okay. So with that, we have
Sir,
completed
thank you,
all
ma'am.
our
Thank you for your
presentations
understanding.
for today. Yes.
Yes.
And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope the session was informative enough. And we, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference. And we will be happy to have you in the 8th version in 2024. So all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. And the publication will be live within 6 months. So kindly cooperate with the team of SMARTCOM 2023. Now I would also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of the whole team of SMARTCOM and Global Knowledge Research Foundation. So thank you so much for your valuable presence, sir.
Thank you to all.
Thank you, Anisha ma'am, and thank you, Dr. Bharat sir. Thank you for taking out time and giving us opportunity to present our paper in this SMARTCOM 2023. Thank you.
Okay, thank you so much. And now I request all the participants to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Thank you. Have a great day. Bye-bye.
You too. Thank you.
Thank you, ma'am.